All right. Or standard Ajax type. Uh, your simple text slash head slash you for the HTTP and the page. If changed, right? So and then session headers primarily cookie knows what cookie. I will call out those who raise your hand. Know what a cookie is. The HTTP response, and I show that can't misimplement this HTTP Drupal. Here's the thing. maximum cache lifetime. And as a consequence, on Varnish, so indeed through Varnish, page 0. This page is not being cached. So if you're responsible for the site, there you go. All right, so what does Varnish do? Varnish sits in between the client and the server, but unlike your client, you spending a whole lot of time inside Drupal tuning Drupal internals. Caches everything else. You absolutely should go down those routes and improve those things. But Varnish is a quick win because it exists outside of all that. No matter how complex you make the site, Varnish sits outside of that, and so you don't have to go in and fix someone else's code that's preventing things from caching. It just works. VCL is what we use to control Varnish. So when I was saying that this is how we make ourselves smarter than the client, this is how we do it. VCL computer concern yourself about multiple requests coming in at once and potentially, getting the request header from one and then asking for another request header and getting the request header from the second. Each individual request coming in spawns, so to speak, a separate copy of Varnish. That is a terrible oversimplification, but in terms of how you program the VCL, you can consider that to be true. Thus, you can use the PHP mindset that you're already familiar with as a Drupal developer to continue to code in VCL. Each request spawns one instance of Drupal. Each request spawns one instance of the VCL. So the default VCL consists of a whole bunch of subroutines. I had to look up this list because some of these never get used. For example, init and fini I have literally never used. I don't even entirely know what they do. Whereas the vast majority of the ones you end up using are receive and fetch are the two most important ones, because those affect what happens when a request is first coming in the case of receive, and fetch is what happens when the data is going back out, when you've either fetched it from the back end or from your cache. So the default VCL receive, I don't know, actually that's pretty readable. The default VCL receive, let's just go through very quickly. We start off by saying if this is not a restarted request, which is a request that has come in a second time, then if we already have an X forwarded for header, then go ahead and add a set the X forwarded for to the previous X forwarded for, but add a literal comma and space, and then add the client IP. So because Varnish acts as a reverse proxy, from the point of view of your web browser, your web server, excuse me, this request is going to be coming in from a server other than the client. So let's say that you were doing something like GeoIP, and using GeoIP you were going to say all of my requests from visitors in the UK are going to go to my UK site, all my requests from visitors in China are going to go to my Chinese site. Right now, if you didn't have this line of code in here, from the point of view of the web server, that request is coming in not from China or from the UK, but from the server sitting 2 inches away from your actual web server, or possibly even from the web server itself on localhost. This is the one case where you do have to You have brute force banning on logins. If you ban someone for brute forcing, you just banned everybody. Congratulations. So this is how we set that header so that later on inside the web server you can use it. If we don't have, this is the else, if we don't have an x-forwarded for header, then we create one and we set it to the client IP. If the request is not get, head, put, post, trace, options, delete, those are the standard verbs that Varnish actually knows how to deal with. So if it's a different HTTP verb, it says, you know what, hands off. I'm done with this request. I literally have no idea what's going to happen next. For all I know, this isn't HTTP at all. This is some other protocol that just happens to be using port 80. I'm getting out of the way. And this is a really handy thing to have. Here what we're doing is we're returning pipe, which says get out of the way. By returning pipe, we guarantee that Varnish cannot mess with this request anymore, right? So imagine that you're trying to debug your VICL, and you can't understand, well, maybe this is a Varnish issue, maybe this isn't a Varnish issue. Well, return pipe right at the top of your VICL, and I guarantee you, whatever the issue is, it's no longer a Varnish issue, right? Because Varnish is just handing it off to the back end. It has nothing more to do with it. If the request is not get or head, then we pass it. So pass is the other return value that we use a lot here. Pass says, I don't have a cached copy of this. Go ahead and deliver it straight from the back end. If there is an authorization header, which is what's used for HT password, or there is a cookie set at all, any cookie of any kind, that is enough to guarantee that it pushes through to the back end. The authorization header is the subject of its own little talk. Suffice it to say that authorization is complicated from the point of view of caching. But this only affects HTTP authentication, not Drupal authentication. If you authenticate to Drupal, you're going to, of course, get a session, which is a cookie. And then if all of those have successfully passed, right, we don't have to return pass or pipe for any reason. Return lookup says, okay, go ahead and see if you have it in cache. If you don't have it in cache, you'll still go ahead and grab it from the back end, but try to serve a cached object, is what return lookup says. Once the response comes back, either from the cache backend or from the web server, we run VICL fetch. VICL fetch by default is very simple. It says if our TTL, which is how long we're allowed to keep this around, is less than or equal to 0 seconds. So if you have an expires header that is in the past, for example, that will set a negative TTL. Or we have a set cookie, which is how we create a new session. Excuse me. Or we have a header called vary equal to star, long story. Then we set hit for pass. This is the one and only case where Varnish can actually slow you down a little. By default, what Varnish does is if it has 6 requests come in for the home page, right, it will block on the second 5 requests in the hopes that that first request coming back will satisfy the other 5. If it doesn't, then it will then very optimistically say, well, you know what, that first one wasn't cacheable, but I bet you that second one, that one's going to be the cacheable one, right? So it's very unlikely that you'll run into this, but if for some reason you do, hit for pass is how you do that. That stores a special object in the cache that says, you know what, if something comes in, it's a cache hit, and by cache hit I mean go directly to the back end, do not pass go, do not collect $200. So that way it saves you from that problem of piling up behind that lead request. If we don't return hit for pass, then we return deliver, which just says send it out. There's actually another thing called VICL deliver that is your final chance to modify things as you go out, but we don't use that very often, so we'll move on. VICL hash. VICL hash is important because VICL hash is what determines the difference from one request to the next. So let's say that you have a request and you're asking for /user, right? Someone else has a request asking for the home page, which is /. Well, Vickle hashes the URL, so therefore those two things are different. If we were to remove this, if we were to remove hash data request URL, then if person A comes in and asks for /user and person B comes in and asks for /, it says, oh, I've already got a copy of that, here you go. And it would serve up /user to the person who asked for /. So what we're doing here is we're differentiating requests. So similarly, if we have a host header, then we hash the host into the object identifier. If we don't, we hash the server IP, which is the IP that they connected to. Because, again, we want to be sure and serve different content to different people depending on what makes their request different. Now, earlier I mentioned accept language. So if we had an accept language header that we're using on the back end to determine, okay, this person prefers to be served content in Tagalog. This one prefers content served in English. The Tagalog speaker gets a page. Well, based on this, the only thing that matters is the request URL and the HTTP host. So when the English speaker comes in, they're going to get a Tagalog page that they probably won't understand. So what we do is we simply add hash data. If request HTTP accept language, then hash data request HTTP is accept language. That then shards our cache out, right? So we now have a separate cache, effectively, for each accept language. So maybe we can make that a little improved. After all, we don't use the accept language header when serving JPEGs, right? But that solves the problem. We no longer serve English content to people who speak Tagalog or vice versa. So let's improve Vickle receive. And the first thing that I want to do to improve Vickle receive is, if you recall, in the original Vickle receive back here, we say if there is a request HTTP cookie, then return pass. So categorically, if there is a cookie, it is something that we cannot serve to you. But we know that things like JPEGs and GIFs and PNGs and GIFs, if you insist, icon files, all these things, right? They don't depend on the cookie. They don't run any code. Going to be the same. So what we say is, if the request URL matches this regex, ends in JPEG. Next thing, remove the cookie from the request. So by doing this, Vickle receive happens before Vickle hash. So all of this now applies, and we know that this is a because only the cookies that are used by JavaScript canonically start with 2 underscores. There are some people out there who mess with that and only start with 1 underscore or use other things. You can imagine that you can change this, but point is, you can actually do very complex cookie substitution. This is an example of a cookie blacklist. You can also do an approach which is a cookie whitelist, only allow through cookies that you know matter to the back end. So that way, even if you add, Optimizely, and then you add New Relic, and then you add Google Analytics, and then you add, whatever Russian tracker is in vogue right now, you don't have to keep updating this list. But either way, point is that you can get arbitrarily complex in these rules, and then ultimately say, okay, after we delete all these cookies out, if there's no cookie actually left, then just remove the cookie line entirely. Now, we've created a bug. Not with this complicated one, but actually with this very simple one. And the trick is that you always have to think about the full life cycle. So let's imagine that we're logged in. We've got our super secret cookie that no one can ever know because it uniquely identifies us, and we request my.jpg. Varnish says, oh, sure thing. All right, so we're looking for a JPEG. That means that I can strip out the cookie, right? So we now hit the back end, no cookie. Here's the problem. My JPEG doesn't exist. And we have something on the page that generates a session cookie for users who aren't logged in. Well, of course, we're logged in, right? But we just got generated a cookie. So that means that Varnish now sends back to the client a set cookie header that says, okay, you're now an anonymous user who hit this 404 page. You go to the next page, and all of a sudden, you're logged out because you have new secret instead of the original secret. This is really, really mind-blowing, right? Because you go to a page, you've successfully logged in, you go to some page, and you're logged in on that page, and then you click on literally any other page on the site, even one that worked on its own just fine 5 minutes ago, and now it's broken. You're logged out. And the only way that you can track this down is to think about the full life cycle of the request, right? Bring up Firebug, Chrome, whatever. There's net panels on all of them. Bring up that net panel and look at the headers going back and forth, and you'll spot it, and it'll suddenly make sense. But outside of that, you can imagine how Varnish is another layer of complication, right? And so its bugs are appropriately complicated. You have to be able to think of the whole thing. So how do we fix this? It's actually not hard. We just say, if the request URL resulted in us stripping the cookie, then we also strip the cookie coming back out. Easy as. Tools that you can use to find this sort of issue in addition to the net panel. There's Varnish log and Varnish top. You can supply the B flag, which says only show me stuff from the back end. This is a request that came in, and Google, if you've modified this page since February, go ahead and give a new copy of it. Apache's either going to say yes or no. You can see that using this, both coming into Varnish, going out from Varnish to the back end. In fact, Varnish by in 60, evict things that way off of red is cached most of the time. Whether for Phoenix, clearly that's Varnish's problem. Don't go that route. Exclude Varnish first. Use Vickle pipe. Use some sorts of errors. If you excluding Varnish first, you have that available to you. Then you means that now we aren't debugging with load going as we took. So I Hi Dan is based on you'll cache all CSS, you'll cache images, you'll start running Varnish here, right? So you've got two basic approaches. And generic for you, degree tests, but usually good ones. Called ESI, which is Edge Side Include. So, is anyone back in the days serve up? Well, and take you out.